Today's lesson 66, theoretical and experimental probability. So let's look at the do now. Complete the following simple probability questions. So a letter from the word photosynthesis, so let's figure out how many letters that is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 letters. Is picked. What is the probability of picking a vowel? So that's a vowel. A, E, I, O, or U. So 1, 2, 3, 4. So there's 4 vowels. So it'd be 4 out of 14. So it's we could reduce that first to 2 over 7, which is 0.2857. And if we make that a percent, move it 2 times to the left, 28.57%. Now, in the same bag with the letters from photosynthesis, so we know it's 14 total still, what is the probability of not picking a vowel? So we do 1 minus the 4 over 14, since this is how many are vowels. That'll give us how many are not vowels. So that would be 5 over 7. So if we do 5 divided by 7, we get 0.71428. So 2 times to the left, 71.43, we'll round it to percent, of not getting a vowel. So let's go over what probability is from yesterday. So probability is a measure of the chance of a specific event occurring. And it's usually written like this: probability of the events. So let's talk about 2 different types of probability. Theoretical probability is what should happen in an experiment So let's look at an example. Would be if you toss a coin 100 times, you would expect to get heads 50% of the time, or half of the time, because there's 2 sides to a coin, heads and tails. Half the time you expect to get heads, the other time you would expect to get tails. So experimental probability is what actually happens after an experiment of many trials. Okay, let's look at number 1. The table below shows the result of rolling a standard die 50 times. So they took a die and they rolled it 50 times. So what is the theoretical probability of rolling a 4? Well, on a die we have 1, 2, 3, 4, 5, 6. So we have 6 total sides. How many of them are a 4? Just one. So theoretically, it would be 1 out of 6 times. Now we're going to use the table. What is the experimental probability of rolling a 4? Well, if we look here, rolling a 4 got us 5 times. And the frequency, we rolled it 50 times. So that's going to be on our bottom. How many times did we get a 4? 5 times. And now let's reduce that fraction. Is this 1 over 10? So the theoretical probability is more than the experimental probability, where this is lower than the theoretical probability. B. The results of spinning the spinner below 75 times are shown below. What is the theoretical probability of spinning a shaded letter? Well, how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 total letters. And shaded, we have 1, 2, 3, 4, 5, 6. So 6 out of 8. So 6 divided by 8 gives us 0.75. And if we make that to a percent, it'd be 75%. Now, what is the experimental probability of spinning that shaded letter? Well, we spun it 75 times, so you don't have to add all these up. They did it for you. And shaded, we had A, B, C, D is not shaded, E, F, G, H is not shaded. So we need to add all these up. So we have 5 plus 12 plus 10 plus 11 plus 13 plus 9. So 60. So 60 out of 75. So 60 divided by 75 is 0.8, which is the same thing as 0.80, which is 80%. So this is actually higher than the theoretical probability. C. The table below shows the results of tossing a coin. You don't know how many times, blank times. So theoretically, how many heads would you expect to occur in 300 tosses? Well, we have 1 out of 2 to be heads or tails. So half of 300. So 300 divided by 2, you would expect 150 out of 300 times, which would be 0.50, which is 50%. So based on the experiment, how many heads would you expect to occur in 300 tosses? Well, here, this is 100 tosses. So 58 plus 42 is 100 tosses. And heads would be 58 out of 100. We could set up a proportion. So how many out of 300 would we expect? So cross multiply. 100 x equals 58 times 300, so 17,400. Divide by 100, one-step equation. So x equals 17,400 divided by 100, 174 times out of 300. So 174 divided by 300 is 0.58, which is 58%. So it would be more than the 50% from part 1.